Hi friends, so now let us continue with the discussion on number systems. Okay, today actually we are not going to start the main portion of class 11 and 12 as I had already said, but there is a bit more which we can cover in number systems and related properties. The thing is, whenever you are studying about something, whatever it be, in whatever subject, science or anything, whenever you study about something, first thing you will study what it is, and then you will be studying its properties. How does it behave in different conditions? Okay, and what are the characteristics that it exhibits, right? So it is only natural that we should focus on the properties of numbers. Okay, basically here I will be discussing the properties of real numbers. Okay, these properties are almost common for all real numbers. Okay, so let us start with the properties. Okay, as I have already said, we denote the set of means the system of real numbers by R. Right. This is not the system of real numbers by the capital letter R. So what are the properties that are exhibited by real numbers? Now before I go into the properties, let me show you 4 symbols or notations. Okay. Basically we need to focus on 2 notations. One is this and other is this. And the other is this or this, means like this, not just. What is this? What is this? This number says that for all or for every. Okay, we will study the usage of these numbers. Say you are mentioning each and every natural number. Okay, so you will write for all x element of n. First let us do element of okay, element of means 1 is an element of the set of natural numbers, right? The system of natural numbers. So we write 1 element of n. This is the short form of writing that statement. Okay, now this second notation is for every natural number element of n, means let's say variable x. For every x element of n, okay, this we have to use this many times in our discussion of class 11 and 12, and also further if ever you are doing in mathematics, physics, chemistry, economics, everything. Take it perennial, anything that includes numbers. And there are very few things that do not include numbers, right? So everywhere it will come. So this notation stands for every element of n. Now the second thing is, this is for sum, or there exists sum. Okay, like for some x element of n. Okay, this is this method. This is such that okay, let's say x is greater than 0. Then we write for natural numbers, always natural numbers are greater than 0, right? So for every x element of n, x greater than 0. This is true, right? This is how we write. For every x element of the system of natural number, x will be greater than 0. Simple. Okay, this is the system of this notation. And there exists some x element of n such that x square is equal to 4. True, right? See, let's take some variable x. for some x element of M, that is, there exists some x which belongs to the set of natural numbers, and this x exhibits the property that x square is equal to 4. Naturally, then x will be equal to 2. Okay. So these are the four basic notations we will be using throughout our discussion of mathematics. Okay. Now, what are the some properties? The first property is the squaring property. Okay. Property is 1 squaring, that is, for all x element of R, x square greater than or equal to 0. For all x element of R, x square will be greater than or equal to 0. You need not verify. If you, whatever number you take, multiplying this by the same number, we get the square of that number. Let's take minus 25, negative 25. Can you tell, because minus 25 is less than 0, its square also will be less than 0? No, naturally, because the square will be equal to minus 25 into minus 25, and it will be equal to plus 625. Okay, so whatever natural number you take, and you cannot multiply minus 25 by plus 25 to get its square, because square means multiplying the same number by itself. Okay, this is the squaring property. Then let us take some star. Okay, star is some operation on numbers. What are the four basic operations you know? Addition, subtraction, multiplication and division. Right, these are the four operations we commonly do in numbers. Not commonly, almost same. The root, square root is there, but we will not consider that here. This is the set of, these are the four basic operations we do on any numbers. So, the star can represent any of this operation. So now let us make a table so I can tell you a few things. Okay, I don't think we need this anymore. So how do we do? First column I will be taking star, and then I am taking plus, minus, multiplication and division. Right. So what is the first property? That commutativity. What is commutativity? Let's take some element of some two elements of the set of real numbers. Let's use x star y is equal to y star x. If this thing is true, then that operation star is said to exhibit the property of commutativity. Is it true for natural numbers? Means, is it true for addition? Naturally, yes. This is true for addition. For addition of 1 plus 2 will also be equal to addition of 2 plus 1. Addition of minus 26 plus root 2 will also be equal to the addition of root 2 plus minus 20. Root minus 1. Something. So whatever be, the property will be true. Okay. The order of addition does not matter. Similarly, whatever be the number, the order of multiplication also does not matter. Okay. 1 into minus 25 will always be minus 25, and minus 25 will 1 into 1 will also be minus 25. So this is true for multiplication as well. What about subtraction? Is 1 minus 2 equal to 2 minus 1? Tell me. 1 minus 2 is equal to 2 minus 1. Can you tell me? Surely it is not, right? I hope you will tell no. Because 1 minus 2 is minus 1 and 2 minus 1 is 1. The sign is changed. They are not equal. So, for subtraction, this property does not hold true. Similarly, for division, is 2 divided by 1 equal to 1 divided by 2? No. No. So this is also not true for division. Now the next property is associativity. Associativity. What is associativity? Since we are using the same star also here, X star Y star Z is equal to X star Y star Z. How will it be true? We are not discussing the property here. Commutativity means X star Y is equal to Y star X. If some operation exhibits this truth statement, then the operation is said to exhibit commutativity. Similarly, for associativity, there are three elements: X star Y star Z is equal to X star Y star Z. If this is true, then that operation is said to exhibit associativity. For addition, it will be true. The order of addition never matters. Similarly, for multiplication also it will be true. The order of multiplication never matters. Now we will consider subtraction. Let us consider two elements, 5, 4 and 1. Okay, 5, 4, 1. And let us consider 5, 1 and 3. Okay, let us see if this exhibits associativity. 5 minus 4 minus 1. What will this be? 5 minus 4 is 1 minus 1 is equal to 0. Now 5 minus 4 minus 1. What will this be? This will be equal to 5 minus 3 is equal to 2. Therefore, it does not apply here. Similarly, it will not apply here as well. Now, I will tell you one more thing. We need to study why I am doing this 4 minus. Why I am doing this 4 minus 3 first is that it is inside bracket. Okay, just memorize now it is inside bracket. I will tell you why. So, associativity is not also applies the similar rule. Now, let us take distributivity. The basic principle of distributivity is multiplication distributes over addition as well as subtraction. This is one property. That is X into Y plus Z will be equal to X into Y plus X into Z. We are first doing X into Y and then X into Z, and we are adding. This will be equal to adding these two and multiplying that sum by X. So it is opposite also. If this X goes here also, there will be no change. Because of commutativity. Okay. So this will be 1. Now similarly, X into A minus B is equal to X into A minus X into B. This is one thing. So this is the property of distributivity. Now there is another property that any given number, let's take the case of natural numbers. It is true for any number. Basically natural number and integers. Any natural number can be represented as a sum of given number of natural numbers in infinitely many ways. Let us represent 9 as a sum of 3 natural numbers. Okay, we need to represent 9 as a sum of 3 natural numbers. Is there only one way we can do? No. There are many ways we can do. Okay, let me tell you how. Or we will take not 9, we will take 15. For I think it will be easier to explain if it is 15. So we have to represent 15 as a sum of 3 natural numbers. Is there just one unique method of representation, or are there only 2 methods of representation? I don't think so. Okay, in related to this, we will study the magic square. We are doing magic square. This is a square and it will have 3 columns and 3 rows. How am I going to make this magic square? I am going to use the numbers 1, 2, 3, 4, 5, 6, 7, 8 and 9. First I am going to write the middle number 5 in this box. Then what I will do, directly on top I will write the least number, that is 1. And then beyond beneath I will write the number 9. What will I do next? This number is gone, this number is gone and this number is gone. Next we will start the minimum here is 2 and I will write this 2 here. Maximum is 8. I will write this 8 here. Then after these two are also striked off, this 3 is the minimum now. In the remaining number, this 3 is the minimum. This 3 I will write here. And 3 and we have 7, right? The maximum here is 7. And then the minimum here is 4. And then the maximum is the remaining one 6. If you add these numbers, 8 plus 1 plus 6 is equal to 15. 3 plus 5 plus 5 is equal to 15. 4 plus 9 plus 2, 15. 8 plus 5 plus 2, 15. And then again 6 plus 7, 13 plus 2, 15. Okay, 10 plus 15. This is also 15. This is also 15. Then this thing we haven't done, right? This is also 15. How many combinations did we get? 1, 2, 3, 4, 5, 6, 7, 8. My God! We got 8 combinations of 3 numbers, the sum of which is equal to 15. So this is one interesting thing. You can take any numbers, preferably consecutive numbers, 9 numbers, and you can try as many magic squares as you want. It is too interesting. Okay. This is actually an important property of numbers as well as it is very interesting also. That is, the most minimum number will be here, the most maximum number. After striking off the next minimum number will be here and the next maximum number will be here. After again striking off, the next minimum number here and the next maximum number here. Again striking off the next minimum and the next maximum. And the middle number will be in the middlemost box. Middle for middle. So this is an important property. Okay, these are about the properties of numbers. Next, let us say that you have many operations. Let's take 1 plus 7 into 3 divided by 8. How will you do this? Do you have any idea? There is a rule called the BODMAS rule that will help us to do all these such operations that have such chain of operations that have many operations, many different operations, such sums which have different operations in them, we will be able to do with this BODMAS rule. What this says is bracket of is generally related to multiplication, but then division, multiplication, BODM, addition, subtraction. This is, so here how do we do? This is the order 1, 2, 3, 4, 5, 6. This is the chronological order in which we should do the operation. Here we have 4 operations. First we should do 3 divided by 8. What will be 3 divided by 8? It will come almost, let me see, 3 divided by 8 will come almost 0.375. Okay, so what will happen? After doing this operation, we will get 1 plus 7. Okay, let me take this. It is getting too complex. Let us take 1 plus 7 into 4 divided by 8. First we are doing 4 divided by 8. What will this come? It will come 0.5. So 1 plus 7 into 0.5. Okay, this is the new operation. Then after division we have multiplication. We will do 7 into 0.5. 1 plus 3.5. 7 into 0.5 is 3.5. Now the only left is addition. So this will be 4.5. This is the sequence we should do. Okay. Suppose you have, but let us say this is 3.5. Okay, is equal to 3.5. Now let us say I am putting a bracket here. Bracket comes the first in the length and therefore I will do this first. So 1 plus 7 is equal to 8 into 4 divided by 8. Then what will I do? Then I will divide. Then I will take 4 divided by 8. That is 8 into 4 divided by 8 is 0.5. Then I will do 8 into 0.5 is equal to 4. This is the answer. There is a difference when we put a bracket. However, we will see the operation that is given. If it is first, if there is any bracket, all the brackets will be done first. How many ever brackets are there? They will always be done first. Then if there is any off, if I put 4 of 8, then after this bracket we will do 4 of 8. Okay. And then we will combine these two operations. Let's try that one. Let us take, we will not take 4 of 2. 4 of 2. First we will take 8. 1 plus 7, 8 into 4 of 2. We will do again, next we will do of 4 of 2 is 8. Then we get 8 into 8 is equal to 64. Again the operation is changing. But what is the given chronology is the BODMAS rule. So this will be with this next introductory lecture, and we have come to the basic requirements in mathematics before starting class 11 and 12 portions and as well as your entrance. So here we saw first what are the properties and some notation, and we studied the BODMAS rule, and we also studied an interesting thing called the magic square. So this will be with this lecture. I will be meeting you in the next lecture. So stay safe. Bye bye.